In this problem, we want to find the general solution of y double prime of x is equal to x over 1 minus x squared to the 3 halves. So this is going to be fun. So the first thing we need to note is, and I'll just kind of put it over here. So y prime, of course, would be equal to the integral of y double prime with respect to x, just like y is equal to the integral of y prime of, dx. That's the fundamental theorem of calculus, right? So FTC note, right? Fundamental theorem of calculus you learn in Calc 1 is that a function is equal to the integral of the derivative. Of course, give or take a constant, but we'll go from there. Okay, so let's start by finding the first derivative. So I want y prime. Y prime would be equal to the integral of x over 1 minus x squared to the 3 halves dx. All right, so I'm going to use a little u substitution here because I can kind of see how this is going to go. U is right there. So u is 1 minus x squared. Du is negative 2x dx. And I don't want the negative 2 part. I want negative 1/2 du equals x dx because that's the piece that I have in my problem. All right, so let's rewrite this integral. And it's going to be negative 1/2 in front. So negative 1/2, that just gets that out of the way. And then it's going to be 1 over u to the 3 halves du. All right, well, that's the same thing as negative 1/2 u to the negative 3 halves du, which is equal to, and then we're going to add 1 to the power, so negative 1/2. Add 1 to the power makes it u to the negative 1/2. Then you multiply by that new power, it's reciprocal. So negative 2 over 1 plus C1. I'll call it C1 because I'm going to have to do 2 integrals here. When we do just one integral, we call it C, but since I'm going to have to integrate again, I'll do C1. All right, so the negative 1/2 and the negative 2 go away, and it just leaves me u to the negative 1/2 plus C1, which is 1 over the square root of u plus C1. And that is, of course, 1 over the square root, and u was 1 minus x squared plus C1. So there's the first derivative right here. I'm not boxing it because it's not the answer. I'm looking for the solution, so I need to find y of x. I just found y prime of x, right? So y prime of x is equal to that integral, which I just did. So now I've got to do it all again, and I've got to do y of x is equal to the integral of y prime of x dx, right? Thanks to the fundamental theorem of calculus, which is the integral of 1, lost my pen there, 1 over the square root of 1 minus x squared plus C1, that C1 is still there, dx. Now, if you're savvy, you might realize you've seen this before. You've seen that integral. That's an integral you know from Calc 1. Let me grab the Calc 1 formula sheet. Well, Calc 2 one and Calc 1 one. So it's the basic integral reference sheet, and you see it right there. It's number 18, right there. That the derivative of a squared, or derivative of du over the square root of a squared minus u squared is arc sine of u over a. So using that idea, we can have our formula. This is equal to, okay, so let me really quickly. So u squared equals x squared, so u is equal to x, and a squared is equal to 1, so a is equal to 1. So using formula number 18, I don't know what it is in the big table. It's in there somewhere too, but so number 18 integral formula. this is equal to the arc sine of u over a, so that would be x divided by 1 plus, x divided by 1, my 1 got weird there, plus, now the integral of this would be c1x, that's a constant, so c1 times x, plus now a new integral constant c2. So we had c1, pretend that's 5, then it would be 5x. If it's 3, that would be 3x, right? And then I have a new integral constant, c2. And there we have it. So y of x is equal to the arc sine of x plus c1 times x plus c2. That is the general solution, and that's all we could find here because they didn't give us an initial condition.